Now we are going to continue. Remember what we did the other day? We introduced so-called probability as a function. This is what we did. Nice and easy case. So we'd like to have the probability as a function. So we're going to have x, which is the variable. Okay, instead of f of x, we are going to have a p of x. Our variables, the outcomes of the variables depends on chance. So that's why we call it a random variable. Okay, and these variables can have a domain of counting numbers, 0, 1, 2, 3, 4, 5, 6. In that case, we refer to them as a discrete variable. Or if your variable can be in, like in calculus, can be in a given interval, for example, all the numbers between 0 and 5, for example, all the real numbers. In that case, your variable is going to be continuous. The result, the function, if you work with a discrete, the function is going to be called, the function is probability function. P of x means probability of getting x. So if your x can get only the number 0, 1, 2, 3, 4, 5, 6, you are in a discrete case. If x can be anything between negative infinity and positive infinity, that would be continuous one. For the rest of the course, we are going to study these two. In this section, we only study discrete one. Okay, so we give a definition. It's just a function. Probability distribution is a function, so it can be displayed by a table, a chart, a formula. And when x is given to, we denote the p of x means probability of getting x. Then we investigate this one. This is probability function, so it got to have two conditions. It cannot be negative. It's between 0% and 100%. And the sum of all the possibilities must be 1. So this is the way we are going to introduce our function, x and the px. For example, for this one, we add them together, we get something above 100%. So this is not going to be a function. Now that we are going to have a kind of new population, we were interested in to see how we can modify the formula for the mean, variance, and the standard deviation with these formulas. So this is going to be our formula. Mu is going to be sigma x px. That would be the mean of this type of distribution. Then we are going to have the variance. The modification of variance is this formula. There's another one in your book. You can use it, but I'm going to use this one. Sigma square, sigma of x square px minus mu square. Mu is the mean. So that would be our standard deviation. If you take a square root, that gives you the variance. And example is very easy, and they give you one on the test. That's it. The result of whatever we did last lecture is going to be this problem. X and the px would be given. They are being asked to find the mean and the standard deviation and the variance. So this is the table that you have to complete. You have the x and the px. It's like the one that we did before for the frequency distribution table. Okay, we substitute, get the formula. So this is all we did so far, or all we know about this type of function. There's a special one. We talk about it when we get to the review. Okay, any question? Now, there is one more interesting problem from this section that we're going to cover it, and that give you one problem again from this one. And that would be a special mean of these type of observations. There is something that in not only in statistics, but also in physics, in mathematics, we call it mathematical expectation. What's going to be mathematical expectation? You see, when there's going to be a procedure that you're going to repeat it over and over and over. You repeat something every day. Okay, you spend enough, a specific amount of money every day. Okay, for example, you buy a lottery ticket. So if your procedure is going on forever, so there's going to be expected, you are going to have some expectation. So when you buy the lottery ticket, of course, your expectation is to win, but most of the time you lose. Okay, or you may buy a life insurance policy, your expectation is to make money. But in that case, you will see that the company is the one who making the money. So when we get to this type of situations, there is something we call it expected value or mathematical expectation. In the case of this probability distribution that we talk about it, that would be exactly the same as the mean. So when you buy the lottery ticket over the years, your expected value would be the average value or the average amount that everybody will lose or expect to win when, 1,000 people, 1,000,000 people, they purchase a lottery ticket, okay? So it's not different from the mean, but the way you are going to construct it is going to be different. You have to create the table yourself, and there is only two possibilities. The possibility is going to be a gain or a loss. So I'm going to give you the definition and to see how we're going to handle these type of problems. Okay, you get a number of them in your book, in your assignment, and they are not going to be difficult, but you have to know it in advance. Okay, so that would be what we are going to argue. Is in the same section, but we call it expected. Okay, what's going to be expected value? For the general case, you need a little bit of calculus to take care of these type of problems, but you are not going to have those general cases. If you get it in future, if you're machining physics, then they are going to give you the definitions. Okay, so it's going to be expected value or mathematical expectation for future. Okay, that's going to be mathematical expectation, but it's going to be mathematically you can expect when you buy a lottery ticket. Okay, the definition as we talk about it is going to be just the average. So let's give you a description of the problem. So this is going to be the average, the mean of a, of course, discrete in this case, a discrete random variable, variable x is what is just the mean of the outcome, is the mean or the average, the mean of outcomes, the mean of outcomes for when you repeat something over and over for infinitely many tries. It must be something that it's going on forever, so that you can expect something. So in this case, what is going to be that expected value that we are interested in? So what is the expected? Okay, expected value. Expected value is the average of this procedure. Okay, it's going to be the average value that we would expect to have to win. Okay, we would expect to get or to win, to gain, get if the trials if the trials could continue forever. Okay, continue forever. So it means if you keep buying the lottery ticket for a long time. So it's denoted by E, okay, for expected. It is going to be it's going to be denoted by E for expected and is obtained and is going to be obtained by the following formula. The formula is the same formula that we use for the mean. Following formula. the mean that will give you the mean delta day. Okay, what's going to be the mean? But we call it expected value. E is going to be equal to what? Sigma of x px. Okay, so the formula is going to be the same, but the context is going to be different in a case that we are going to have. Okay, so that's going to be the one. What's the question? Everybody's in? So that is going to be, that's going to be the case. Just checking if anybody is out yet. Okay, so it's denoted by E and it's obtained by the following formula. So the formula is going to be the same, but you are going to use the notation of the E for the, okay, for the expected value. Okay, any question? So instead of, finding the mean, or you may be asked for the expected value of the situation you're going to have. So the case is going to be a discrete probability and the formula is sigma xpx. But as you are going to see, you have to design that P of X yourself. That's it. That's the main part of this type of problems. Okay. So I'm going to give you two examples, and you have two in your practice test that we're going to post. Probably you get one take on one for this one to practice. So you're going to have one on that one too. Okay, so it's going to be the same. The first one is like the lottery ticket that we talk about it. You see, sometimes there is a party, there's going to be a charity, something. This is the way they are going to do it. They are going to sell some tickets. Okay, so let's say 1,000 tickets. 1,000 tickets are sold. 1,000 sold at what? At $1 each. Okay, $1 each. You buy a $1 ticket for a price of, or a color TV. Okay, color television valued, color television valued at $350. Okay, so there are going to be 1,000 people. They buy ticket. They purchase ticket $1 each. Okay, but the winner would get the TV set valued at $350. Okay, suppose you buy one ticket. What is going to be your expectation? What's going to be your expected value if you buy one? Okay, so I want to know what is going to be the expected value. Okay, what's going to be the expected value? Expected value of the gain. Okay, if you purchase one ticket, okay, you buy one ticket and take part in this game or charity. So we want to know what's going to be expected, your expected value. Okay, so this is going to be the case. Any question? Now you have to design the table yourself. Okay, that P of X that we talk about it, you have to design a table and you're knowing that you are going to lose or you are going to gain. Okay, on the test, you need the table. You cannot do just the operation. You have to tell us how you're going to design it. So this is going to be the table that you have to design. So as we did it before, okay, this is going to be over X, okay, and this is going to be over PX. So over here is going to be your gain, what are going to get, okay, and this is going to be the loss, because there are going to be only two possibilities. You may gain or you may lose to get these numbers. Remember, you purchase one ticket out of the 1,000, And if you win, you are going to win a TV set for $350. Okay, there you are. If you win, what's going to be your gain? Any suggestion? Gain
350.
350. Not completely, but you already done something else. 349. Jordan, you're right. Okay, you say $350 to your right, but you already purchased one ticket. Okay, you paid $1. So your gain is going to be the price, 350. Okay, it's going to be 350, but minus one, because you have to buy the ticket to get into it. Okay, so which is going to be 349. Be careful for this one, because you have to do the action, the first action first. Buy it first. Okay, any question? So that's going to be the gain if you win. Okay, how much are you going to lose? What's going to be the loss? Remember, the price of each ticket is just $1. So you're going to lose $1. Yes, Clayton, you're right. You see, because you buy one ticket to participate. So your loss is going to be $1. So you're going to lose $1. So what we usually do is for the loss, we identify the loss by a negative sign. Okay, so the gain by a positive number, but the loss by a negative number. Any question? So you gain $349 because you already paid $1, and then you are going to lose $1. Okay, there you are. Now the probability. Remember, 1,000 people took part in this, and you just buy one ticket. So your gain, what is the probability that you are going to, okay, you are going to win? Any suggestion? Remember, there were 1,000 people and you are only one of them. No. Yes, Kylie, you're right. Yes, 1 over 1,000, 1 out of 1,000. Because there was 1,000 ticket, but you only purchased one. Okay, so your chance is going to be, your chance of winning is going to be 1 over 1,000. 1 over 1,000. Okay, any question? Okay, what's the probability they're going to lose? You did buy one, and there were 1,000 people. Your chances of buying or winning is 1 out of 1,000. So what's your chance of losing?
Wouldn't it be the same thing?
No, it cannot be the same thing. You know that the sum of the probability of all the action must be what? Must be equal to 1. So it must be the complement. Yes, Clayton, you're right. Ethan, yes, very good. Yeah, it's the complement. You see, there were 1,000 tickets. Your chance was 1 out of 1,000. So the complement is going to be 1,000 minus 1, which is 999 out of 1,000. So this is going to be the probability that you are going to lose. It's like when you buy a lottery ticket. The probability of loss is much greater than the probability. Okay, remember the complement. If you add these two together, you must get 1,000. Remember, because this is only two possibility for this type of problems: possibility of winning or losing. Okay, any question? So you've got to be careful, to set up this table correctly. But otherwise, the rest is easy because your formula is what? You see, this is your formula: sigma of x px. So what you do is you just multiply this x and the px together. So this is going to be the result. E is equal to the sigma of x px, which is equal to, you see your x here is 349. So that's a 349. You multiply by 1 over 1,000. Okay, plus, don't miss this negative sign that we have for the loss. It's a -1. So your sprint is going to be -1 times 999 over 1,000. Okay, so this is going to be equal to the 349 over 1000. It's going to be minus 999 over 1000. You can use your calculator, just subtract it. If you subtract it, that gives a negative number, 349 out of 999, so that gives 650. So we're going to be 650 over 1000, which is going to be negative $0.65. Okay, so it's going to be a negative number because you lose. So it's going to be negative, and the number is 0.65, which is 65 cents. Okay, it's going to be negative 65 cents if you like. So this means for the people who participate in this game, on average, each one of them will lose a negative, will lose 65 cents. And on the other side, the company or the guy who set up this game, on average, will gain 65 cents from each ticket that somebody will buy it. Okay, so that's going to be the expectation of you, and this is going to be from your point of view. You can set up this formula against the company or the organizer point of view. The organizer point of view, they are sure that they are going to win money because on average they are going to win $65. Okay, so this is how we set up this type of problems. I'm going to give you another one which is very popular. Just make sure you understand how to do it. Any question? You have some nice one in your book. So you've got to be careful when you set up the table. We need that table from you. Okay, the gain and the loss. When you do a couple of them, you will get the idea. Because the probability would be the complement of each other. So as soon as you find the first one, the leftover out of one is going to be the other one, or 100. You got to be careful about this loss. The loss would be a negative number all the time. Okay, any question? I'll give you another one. This is very popular. We call it insurance policy. That's the one that you buy an insurance policy, life insurance, okay? And you hope to win money, but you will see that we check to see from company point of view how much money they are going to make. Okay, so it's going to be the second example. You have two of these in your book, probably. Okay, what's this? We explain the insurance policy. So there you are, an insurance company, whatever you like. That's going to be an insurance. Okay, insurance company. Insurance company charges, let's say somebody like Mike, $250 for 1 year. It's going for 1 year, 100,000. 1 year, $1,000 life insurance. Life insurance policy. Okay, so you pay 250 for the fee. Okay, 250 for fee, and your insurance policy would be $1,000. Okay, that's going to be the one. So there is a 0.9985 probability. Okay, probability that he will leave. He will be alive, okay, for a year. That's almost 100% if you're a young person. This is the probability that you're going to be alive at the end of year. Okay, so this is it. We want to know what's going to be expected value for the Mike. If Mike purchased the policy, purchase the policy, what is the expected value? What is going to be the expected value? You can have the expected value from my point of view or the company point of view. Both of them would be the same, but for one of them would be negative, the other one would be positive. We go from the my point of view. Okay, everybody understand the problem? 250, that's going to be the fee, $250. And that's going to be the one that you're going to buy the insurance policy, $100,000. And this is the probability that Mike would be alive at the end of the year. You want to know whether he's going to win money or not, or gain the money, or what's going to be the average expectation for everybody who purchasing this policy. Okay, solution. Again, we have to set up the table. Okay, to take care of that one. So this is going to be the case. As usual, this is going to be the X and this is going to be the PX. So we want to know what's going to be the gain. That's going to be the gain. And what's going to be the loss. Okay. There you are. Again, remember $250 for the $100,000 insurance policy. That's about. Okay, what's going to be his gain in this case? How much money is he going to collect?
100,000?
100,000? No, not.
Are we talking about Mike?
Mike, yes, that's Mike. And the insurance policy 100,000, but you have to do something first to get to the 100,000.
Oh, we have to subtract the 250 fee. That's
it,
right.
Yeah, that's 250 fee first. Yes, it's gonna be 100,000. Okay, yes. It's always, that's a tricky part. 100,000, but remember, we have to buy first. So it's a minus 250. So that's going to be the gain. Like the lottery ticket that we talked about it. Okay, you have to purchase first. You have to purchase the policy to get the money. Okay, so that's going to be how much he's going to be gaining. What's going to be his loss?
The 250.
250. Remember, the loss must be identified by a negative sign all the time. So it's going to be $250. That's it. Now, the probability. Remember, the probability that the young person would be alive at the end of the year is going to be almost 100%. It's 0.9985. Okay. Let's see how he's going to gain the money. Okay, the Mike. Remember, it's insurance policy. So he's going to gain the money if he's dead. He's not alive at the end of the year. Okay, he will get the money if he's not alive. So what's the probability of he's not going to be alive at the end of the year?
It's the complement of that number.
Excellent, yes. The probability that the person would be alive is this one, 0.9985. So it's going to be the complement of this number, which means 1 minus this number. Yes, you are right, thank you. It's going to be 1 minus 0.9985. You see, because the probability that if you get the money, you get the money if he's not going to be alive at the end of the year. The probability that he is going to be alive is this one. Yes, we subtracted that, it was 0.0015. Okay, any question? And what is the probability that we lose the money? If we lose the money, what? he lose the money if at the end of the year he's still alive. You see, he lose the money if he's still alive. And the probability that he's going to be alive is 0.9985. Okay, so that would be 0.9985. See, as I told you in your book, sometimes they ask you to set up the table from the company point of view. This is from my point of view. If it's going to be company point of view, you switch these two. And this is just a generally speaking about the, okay, the policy from the my point of view. Okay, any question? So he will gain the money if he's not going to be alive anymore. The probability that he's going to be living through that year is almost 100%, which is 0.9985. So he's going to be dying, okay, with the complement of the probability, which is 1 minus 0.9985. And he will lose the money. He'll lose the money if he's still alive at the end of the year. And the probability is going to be almost, okay, probability would be almost 100% that he is going to be alive. Okay, so that's it. That's the table that we need. We can take care of these numbers, then going to the, okay, to the expected value or write it down. It doesn't matter, whichever you feel comfortable. So if you subtract these two numbers, as some of you noted, that give you 0.0015. Okay, and if you subtract this one, is giving you what? Giving you $99,750. Okay, or you can write it down, just do it. So the formula for the expected value, as you know, is going to be sigma of xpx. That is going to be expected value. Then you multiply the x's and the px. So in this case, the x is going to be 99,750. Okay, times it by the probability, which is a 0.0015, plus, make sure you have the negative sign here. That's the loss. So that's going to be negative 250 times it by the probability, which is 9985. Okay, any question? Don't miss that negative sign. So you can use your calculator to get these numbers. So I have 149.625 minus 249, 249.625. Okay, that's going to be the one. So the result's going to be negative 100. So the expectation is going to be a negative for my point of view, and it is $100. But that would be, if you do it from a company point of view, this is going to be a positive number for them. So the people who purchase the policy, on average, each person would lose $100. Okay, and the company would collect this $100. So the company on average will get, they are sure that they are going to collect $100 at least from each policy, even they, you know, they have to repay some of the, okay, some of the gains. So that would be the case. The best case is if D is going to be 0. If it's going to be 0, it's kind of 50-50 chance for the company and the who person, which who know whom you buy, you know, or buy the policy. So that's a problem of the expectations. That's a good one. It's we call it a finite case in this case because, you know, we have to, this possibility over here. In future, you can have a kind of this is for the discrete probability. Remember, your x is dot dot dot. If this x is going to be a continuous one, then this problem getting a little bit more, not difficult, involved. You need a bit of calculus, because in that case, we are not going to use the sigma. If you have done a little bit of calculus, at least calculus 1, this sigma xpx would be changed into something like integral of xpx, and then you have to integrate it. And this function is going to be kind of exponential function. So we see something like integral of x e to the 2x, you know, if you are familiar with this type of ideas. But from our point of view, that's it. This is what we do in this statistic course. Okay, any question? So interest problem, we're going to check it. Of course, we give you one on the test because this is very important concept that you have to know. So that is 5.1. There is one more problem, but I like to go to that problem not your book, but we can talk about it on the review. One of those problems that we're going to set up. Okay, so that gives us a chance to go to the 5.2. You see, in a statistic, this is discrete probability that we're going to talk about it. For the discrete case, this was a general case. All the other, almost all of them in a discrete cases would be a situation that we're going to call it binomial distribution. That's a 5.2. We check that one to see if we can do all of them or almost half of it for your test. After that, we go to the continuous one. And in statistics, most of the time, or almost all the distribution is going to be continuous. But you need to go through that, the binomial case, okay? So I'm going to give a little bit of those binomial to see how far we can go. And then to see when, how, that's it, how much we can get from that. Okay, that's a 5.2. Any question? So this 5.1, I just checked the problems what to do on the March 20. I just changed them. I give you at the end of I think this week. So if you check, I'll change it. I think I changed it to the 27 maybe for the problem that was due last few days. Okay, so double check it. I should get it because some of them you need it for your next test. Okay, any question? No. Let's see what's going to be this binomial case. Binomial case is very easy, and you have to set it up. You see, setting up the problem is important. Otherwise, it's quite easy problem to handle. To give you one of them on the test. Okay, so what's going to be the idea of the? So what we did so far is X was a discrete probability. X is a discrete variable 0, 1, 2, 3, and these were all general cases. We are going to, from now on, we are going to look into the one special case of this discrete probability function, and future you will find out this is the only one that you are going to have. Okay, so let's pay attention how I'm going to set up this problem. It's called binomial distribution. Okay, it's X is going to be discrete, but the situation is very a unique situation. What's this unique situation? You see, we are going to consider most of the time when we consider the probability situations, you are looking for outcomes. You are going to look for the situation that you are going to have only two outcomes, like the one that we did. You see this one? When you buy this probability, when you buy a lottery ticket, so the outcome is going to be two cases only. You may win or you may lose. Okay? Or if you toss a coin, you may get a head or you may get a tail. There are only two possibilities. So it depends what are you looking for. If you're looking for head is going to be for you a success. And the tail would be for you a failure, if you like. Or, a situation that we ask you, do you smoke? You answered yes or no. So there are only two outcomes. We call it the binomial case. But if I ask you which brand of cigarette, do you smoke? In that case, you may have given me several answers. So that's not going to be binomial. So we are going to consider probability experiments that involve something that you repeat over and over, but all the time, there are only two possibilities for your outcomes. You may get it or you may not. Okay, this is called probability. It's called binomial distribution. And there is a formula for, you may try tossing a coin 1,000 times. So from the 1,000, sometimes you get head, sometimes you get tail. You may be interested in a specific number of successes, a specific number of heads. You may say, I toss a coin 1,000 times. I want to know what is the probability that I will get 100 heads. This is a case for the binomial distribution. Getting it, we call it success. Not getting it, we call it a failure. And there is a formula that give you probability of success. You can use your calculator right away, or you can use some tables. I posted the table for you. I explain both of them. On the test, you have a choice. You can use either one. Okay, so that's the story of the binomial distribution. As I told you, we have to set it up, understand it. At the end, easy formula. We call it binomial distribution. Binomial distribution. For these type of ideas, okay, that's a section 5.2. 5.2. A couple of things that we need from algebra, because we are not going to use the formula, we are going to use calculator, but to get to know it, we need these notations, okay? But at the end, don't worry about the calculation of these terms that I'm going to talk about it. The terms are going to be first one is what is factorial? Okay, what's going to be factorial? We have seen it before. If a number is given to you, the product, if the number is 5, the product of 5 and all its smaller numbers, we are going to call it a 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, so if n is a non-negative numbers, means positive or 0. Negative number. Okay, then n factorial, n factorial. N factorial is denoted by, this is the notation. The notation is n factorial. So we write it down. Okay, in English, this means something else, but in mathematics, this is what we are going to refer to it, and is defined by, and is defined by 0 factorial, we define it to be 1 because it's useful. But n factorial is the product of n and all the previous numbers or smaller numbers. So it's going to be n factorial is a product of 1, 2, 3, up to the n. That's n factorial. Okay. Therefore, it's very useful in statistics and computer science. Therefore, 1 factorial is 1. Because there is no possible number less than 1. Okay, 2 factorial is a product of 1 and 2. So that gives you 2. Okay, 3 factorial is a product of 1, 2, 3. So that gives you 6. Okay, just a couple of them that we need. 4 factorial is going to be 1, 2, 3, 4. Okay, which is going to be 2 times 3, 6, 6 times 4, 24. And you can go on. So for example, 5 factorial. You already got the 4 factorial, 24. If you multiply by 5, that gives you 5 factorial. Or you can write it down. It's going to be 1, 2, 3, 4, and 5. So that gives you 120. Okay, that would be 5 factorial. We are going to use it in the counting problems, if you like. So one version that we use in computer science or later on in counting, not in this course, is that suppose you have, you have 4 boxes. So these are going to be 4 boxes. Okay, there's going to be boxes. Like the mailbox, pigeonhole, we call it. And then you have 4 letters. Okay, these are going to be letters. So if you have 4 boxes and 4 letters and you want to put the letters in the boxes, okay, the letters that you have, they're going to be, you see, these are going to be 4 letters if you like. So if you want to put the letters into the boxes, for the first box you have, okay, this is it. You put 1 into the first one, okay. If you put the 1 in the first one, you have, okay, for the first one, you have 4 choices because you pick any of these 4. So you have 4 choices over here. But when you get to the next one, you already have one of the letters here. So there were 4 letters. So you have 3 choices over here. So you fill up this one. So you have 3 choices over here, okay? But when we get to the next one, when we get to the next one over here, okay? So already 2 letters gone, so you have two choices for this one. So that give you 2 choices, 2 choices, and at the end, you are going to get only 1 choice, 1 choice. So the total number of the choices, ways that you have to distribute 4 letters in 4 boxes are going to be, you have 4 choices for the first one, 3 choices for the second one, 2 choices, and then 1. We call it the product rule, like the probability that we did before. So that give you 4 factorials. 4 factorial, and the 4 factorial is okay to get these numbers. There are various cases, but this is the one that we need, you know, to think about it, to get, you know, to get this one through. Okay, so this is the notation of the factorial that we need. Any question? One notation is why we call this one binomial case. That's a binomial expansion from algebra. Remember that? Binomial expansion on identity. You see, the binomial expansion that you have in algebra is binomial. You know that binomial form is just 2 terms. So if you have this, the first binomial expression, a plus b to the first power would be a plus b. Okay, if you get a plus b squared, you can FOIL it if you like. Then it's going to be a squared plus ab plus ba plus b squared. We usually write it down as a squared plus 2ab plus b squared. That's a plus b squared. We can do the same thing with the ab plus b cubed. A plus b cubed, you know, it's going to be eventually a cubed. Then that give you 3a squared b plus 3ab squared. Okay, plus b cubed. And you can go on forever to get a plus b to the end. Okay. Any question? Do you remember these from algebra? Now, how we are going to use it is going to be this one. You see, for the first case, suppose you toss 1 coin. If you toss 1 coin, the possibilities are going to be head and tail. Okay, it's going to be head and tail. So you get what? I'm going to call the head as success because I'm looking for the head, and the tail as my failure. Okay, so head, for example, is my success, and tail is going to be my failure. So if you can see, if this is going to be represent the success and the failure, this means that when I toss a coin 1 time, I get 1 success and 1 failure. See, the coefficient of the A is going to be my success, the coefficient of the B would be my failure, if you like. Okay, this is when I tossed, I chose one coin. So I'm going to call it N equal to the 1. But if you toss 2 coins, what's going to be the possibility when you toss 2 coins? You see, if you toss 2 coins, you know that the possibility is going to be what? It's going to be head, so it's going to make success. Okay, I may have head and the tail, success, failure, or I may have a failure, success. Then I have the failure and the failure. Okay, I may get, I may get 2 heads, 2 tails, head, tails, tails, head. That give me all the possibility that I have. So I can represent it here. Look at this one. I can think about the A squared as A times A, so that give my double success. So this ABBA would be represent when I get a success, failure, or failure and success. And this last one give me what? Give me failure here. But when I put them together, I can tell you that you see 2AB is going to, maybe I'm interested to see, okay, I would be interested to see that how many times I will get, okay, one success, if you like. So there are 2 places that I will get one success on, exactly one success. Okay, there are 2 ways that I will get it. I may get a success and a failure, failure and success. Or how many times I will get success, it's going to be the case. And you can continue. If you get 3 cases here, you see if you toss a coin 3 times, what's going to be the possibilities? If you have the 8 possibilities, you see, you may have a success, in this head. Or the other one that we did the other day for those 3 years that we talked about it. So it's going to be success, failure, success, failure, success, failure, success. So there are 3 cases that I will get 2 successes. You see, 3A squared B means 3AAB. So there are 3 cases, exactly 3 ways that I may get, I may get 2 successes here. And then we continue, we get a failure, success. Okay, that would be fail, success, and the fail. And eventually this is going to be success, failure. So there are going to be 3 cases as well that I'll get 2 failure, AB squared. Okay, and this B cube would be what? Would be failure. You see, we are going to connect this one to the real case that we're going to have for the binomial cases. So what we are going to be interested really is that, for example, this one, the question is going to be, they are going to ask you the question. They say, okay, suppose you toss a coin 3 times. Toss a coin 3 times. Give us the probability that you will get exactly 2 successes. The probability that you get exactly 2 successes. So you are going to consider how many times are going to get 2 successes. You see, 1, 2, 3. 1, 2, 3, and then you multiply the probability together, because these cases are going to be what? These cases are going to be so-called independent. Remember independent events? When we get independent events, in that case, the probability of and would be the probability of multiplying all the events together. So for example, the probability of getting only 2 successes, you see, 2 successes. Look at this one. The probability of success is 1/2, 1/2, and the 1/2, because probability of failure is 1/2 again. Or this one over here again, probability of success 1/2, failure 1/2, 1/2. And over here, the probability would be 1/2, 1/2, and 1/2. So all of them would be 1/8. But how many do you have? You have 3. So that gives you 3 times 1/2 to the third. Be exactly these coefficients that we're going to know. We are going to have over here. So this is the one that we're going to investigate in general. And to give you a formula, it's just tossing a coin. So it is going to be a situation that's going to have n tries that repeated over and over and over. And you'll be interested in a specific number of successes. So the success is the one that you're going to identify for us. Then we give you easy formula to find all of them. Give you a break for 10 minutes. We come back, we introduce the problem. Okay, that's very a special case, but I put them together nicely. But if you understand this, that would finish everything for us. Okay, think about it. So it's 11:26, 10 minutes. We come back to see if we can get it for you. Eventually, very easy formula. Okay, see you then. Oops, let me get back to this. So I keep it so I'm not going to lose it. Okay, let's continue getting the definition. So we're just building up the case for the binomial distribution. Okay, just give you the situation they're going to be having in algebra or in everyday life. So let's see what is going to be the exact definition of this binomial distribution case, okay? So it's going to be a situation that the outcomes are going to be just two cases, okay? We can brand one of them as a success, the other one as a failure. Okay, so this is going to be binomial distribution. Okay, I just remind you that what would happen or when we are going to use it. I'm going to tell you that many problems in everyday life involve this type of experiments in probability. Okay, in probability and statistic. And the statistics concerned with, okay, concerned with the repetition of something. Okay, repetition or trial with the repetition of an experiment. Do something over and over and over. Okay, experiment that has two possible outcomes, okay? Two possible outcomes only. So this must be the key that we're going to have. In this case, each repetition one, there's an expression that we use. Okay, in this case, each repetition is going to be called a trial. Repetition is called okay, it's going to be called a trial. Okay, like tossing a coin, okay, getting a head. Tossing a coin 50 times and getting a head. You want to see how many times are going to get a head. Okay, the situation is going to be in each repetition, there are only two outcomes. One of them we're going to call it success, the other one we're going to call it a failure. So what is going to be a binomial trial? There is one more distribution in between. They call it Bernoulli distribution. We are not going to do it. In some books, they do it. So we're just going for the binomial trials right away, if you see it somewhere. So what's going to be a situation we're going to have? There are some terms that we're going to use. So we call it a binomial distribution. And these are going to be the following. A binomial trial, or something that we repeat over and over. A binomial trial is going to be an experiment with the following condition. An experiment that satisfies the following condition. Following conditions. Condition are going to be, you should have a fixed number of the trials. This repetition must end sometimes. Like you cannot go in forever. Okay, you toss a coin 10 times, 20 times, not forever. If you do it forever, that's a Bernoulli trial, but we are not going to check that one, okay? So the first case is going to be, Okay, there are a fixed number of repetition or trial. Number of trials. So you have to stop somewhere. The number of the trial is very important. We denoted by n. The number of, especially when you want to use your calculator, this is the notation that you use. The number of tries or repetition is going to be denoted, okay, is denoted by n. So n would be the number of the trial, the repetition we're going to have. Okay, that's a case one. That's the first condition that we're going to have. The other one is in each trial, you should have only two outcomes. If you toss a coin, you may get a head or you may get a tail. Okay, two outcomes only. So the second condition is going to be, that's the second condition. Each trial, each repetition, each trial has only two outcomes. Two outcomes. Okay, two outcomes only. Two outcomes. And the outcome is going to be called success. Okay, two outcomes. One of them is going to be called success. Success denoted by S. Okay, success denoted by S. And the other one is going to be a failure denoted by F. You have to identify which one is the one that you are interested in. You call it success. If you toss a coin, getting a head is your favor. So you are going to, your success is going to be getting a head. Otherwise, it's a failure. Okay, and a failure denoted by F. Okay, the success would be denoted by S, as I did it in that example for you. Yeah. That would be the case 2. Any question? The case 3, which is very important for us. Okay, case 3. The case 3 is, as you go on, the probability of success must be always the same, or the probability of failure. So this means if you toss a coin 50 times, the probability of getting one success is always half. And the probability of getting a failure is almost half. Okay, so that would be very important for us because we're going to set up the formula according to this fact. So for each trial, okay, for each trial, the probability okay, the probability of success, to see here, probability of success is going to be the same, this is denoted by, it's a fixed notation in the statistics, denoted by lowercase p. It's denoted by lowercase p in the statistics, means p of the probability of success for the binomial distribution. Don't miss it. Okay, the probability of failure is going to be when the probability of success is always the same, and there are two cases only, so the probability of failure would also be the same. So the probability of failure, the probability, okay, the probability of failure is going to be denoted by lowercase q. in statistics, anytime you see p, lowercase p, lowercase q, it means you are in a binomial distribution. And note that, remember, in this case, we have only two possibilities, success or failure. So you know that the total number of the total of the probabilities in any experiment must be 100%. You have only two cases, probability of success of the P, probability of failure of the Q, nothing else. So if you add them together, okay, so P plus Q is always equal to 1. And in particular, this is the way we're going to use it. Q is always 1 minus P. So most of the time, P would be given to you. You want to find the Q, you're going to use this formula. In case of tossing a coin is the same. Probability of getting a success is 1/2, and probability of getting a failure would be 1/2 too. And in all the other cases, as you read the problem, as soon as you identify your success, you must look for the P. This would be given to you, probability of success. Okay, you identify it. As soon as you get the P, then you go and you get your Q, which is 1 minus P. Any question? And the reason is, we talk about it. We have only two possibilities, failure or success. So the total number of the probability 100% or 1. So if one of them is given to you, which is the P, so we can find the Q 1 minus P. So that would be case 3. And one more, case 4. Again, case 4, very important. You see, this is a repetition that you do, 50 times, 60 times. And the other case is, each trial is going to be one event. You see, if you toss a coin once, this is one event. And if you toss a coin twice, that would be another event. All these events, which means the trials, they must be independent. Remember, independent event is the one that probability of one of them is not going to be affecting the probability of the other one. And therefore, if you want to use the probability and probability, remember probability of A and B would be probability of A times B. And in this case, you want to have 50 successes, for example. So we're going to have 50 events. All of them are independent. So the probability of getting all the events would be what? Would be probability of one success is P. Probability another success is going to be P. So for example, P to the R is going to be probability of getting R successes. So that would be very important for us to be able to do the formula that we're going to invent, okay? So the trials are going to be independent events. And therefore, we can use the product rule. Independent and the trials are going to be independent and repeated under same condition. Repeated under, you're not going to change it, okay? Identical conditions. I just remind you that in this case, one can use multiplication rule for independent events. Independent events, which is probability of A1 and A2 and AN is equal to probability of A1, remember, probability of A2 up to the probability of A n. So this would be the crunch to make that, okay, the formula that we're going to investigate to get these numbers. Okay, any question? So I just posted some example for you. This is the one that I already posted. So I give you the explanation. You can write it down later if you like, just for your information to get to know these. Okay, and you have some problems in your book. They're not going to directly ask you a question, but it's nice for you to understand what is going on. So you look at this one, this example. They ask you which of the following. I've already posted the binomial distribution that you have in this one and the table that I'm going to explain later. So they ask you which of the following are binomial experiment. Binomial experiment means the outcome must be, okay, fixed number of the trials and the outcome with two possibilities only. Okay, I just go over it, you can write it down if you like for yourself later. But just get to know the situation you're going to have. So the first part, surveying 100 people to determine if they like, whatever soap, Sarvisi soap. So the number of the people is 100, is like the number of the trials. And you just ask the question, do you like it or not? Okay, so the outcomes are going to be two cases. You may like it or you may not. So that is a binomial case. Any question? So 100 people would be your trials. You go from one person to the other person and you ask this question. The second one, tossing a coin 100 times to see how many heads occur. Again, it's a binomial case. Because when you toss a coin, there are two possibilities. You may get a head or you may not. So that would be also binomial. The second one, drawing a card from a deck and getting a heart. Most of the people, they miss this one. They say, no, it's not. But it's a binomial. When you draw a card, there are two possibilities. You may get a heart or you may not. That's it. So two outcomes. So therefore, some people, they say, oh, it's several cases. I may get aces, king, queen. Yes, but you are interested in heart. So you may get a heart or you may not. So two possibilities, therefore it is binomial. Okay, any question? The next one, asking 1,000 people which brand of cigarette they smoke. You see, when you ask for which brand of cigarette, you may get several answers. So you're not going to get only two outcomes. You're going to have several outcomes because you ask for the brand of cigarettes. So this is not going to be binomial. Okay. But any question? So it's not binomial because you may get several answers, not two outcomes. Number 5, testing 4 different brands of aspirin to see which brands are effective. Again, it's not a binomial because you're just checking different brands, okay? If you just check one brand of aspirin to see if it's effective or not, that would be binomial, but they ask for the brand. Okay, so it's not, but the next one, testing one brand of aspirin. If you have only one brand, using 10 people, and then you check to see whether it's effective or not, okay? So the number 6 is a binomial case because you're just asking question yes or no. Any question? The next one is clear, asking 100 people if they smoke. Yes, I ask you, do you smoke? You say yes or no. So that's it. I go around asking 100 people. So that would be a binomial case. Okay, again, the next one, checking 1,000 applicants to see whether they were admitted to CSUSM. So your application is going to be accepted or rejected. So 2 outcomes again. So that would be a binomial case. Okay, question. Next one, interesting, surveying 300 prisoners to see how many different crimes they have convicted of. Again, you're looking for how many different crimes. So they may give you several answers. So you're not going to have two specific answers. So in that case, this is not a binomial. Okay, it must be yes or no. But the next one you see, serving 300 prisoners to see. Prisoners to see whether this is their first offense. Okay, that would be binomial because you asked the question, is it your first time? You may say yes or no. So that would be a binomial case. Okay, any question? So as you can see, most of the situation that we're going to have in everyday life, it would be binomial case, or the cases that we're going to know we're going to have. Okay, so as I told you, you have this one, it's posted, you can have a look at it. And when you go through the assignments, probably on the web, they are going to give a situation like this one to see if it's going to be binomial or not. Okay, let's go back to see what we are going to be interested in. You see. So as you now find out, we are going to have a situation. We are going to have something that's going to be repeated n times. From that n times, you may get some successes or you may get some failures. So we want to know, do we have a formula for the probability of getting some of those successes? Okay, you toss a coin 50 times, you would like to get 25 hits. So what's the probability of going to get it? Okay, so I propose the problem and I write the solution for you. It's very easy formula. Problem is, or the question is this one. Just to understand what's going on and then the answer. There you are. Suppose. Okay, suppose we have a binomial case. We have a binomial experiment, we call it. A binomial experiment with n trials. With n trials. In something that's going to be repeated n times. So what's the question? In your book, the notation I'm going to use, they use X, which is not a very good one. We use R, but I'm going to explain it. You see, because if I go with the notation of your book, but I change it later. If X is the number of, on the calculator they use R. If X is the number of successes, X is the number of successes out of n tries. So you repeat something n times, X number of the times you get what you are looking for. So then P of X is probability of getting X is the probability of getting X successes. X successes out of n trial. You toss a coin 100 times. What's the probability of getting 50 hits? So the question is going to be, what is the formula? The formula for computing what is the formula for computing for computing P of R, P of X. I just go with the R because that's what I'm interested in. What's the probability of, what's the formula for computing P of R? Okay, probability of. The way I did it for that formula for you, I just explained it. I can give you the formula right away, but I would like you to get it with algebra involved to get it. Okay, then I write it down for you. That's the way I just give you these possibilities that we have. It's going to be same thing here. So to give you a little bit try explanation, but get the formula. Okay. If you don't like this explanation, you just memorize the formula. Okay, that's one. Now, that's it. We start the probability of one success is P. So if P is going to be, is the probability okay, is this going to be the probability of, okay, of one success, and as we talk about it, Q, lowercase both of them, is the probability of one failure. You know that you have only these two cases. Okay, it's going to be the case. Now, note that this observation, remember you repeat it over and over. Note that the events are independent. The events are independent, means you can use the product rule. And so, by the product rule, okay, by the product rule, what we are going to do, the probability you want to get X successes, remember, of getting X successes, lots of S's here, of getting X successes, and at the same time, the leftover, and N minus X failure, because there are two possibilities. You may succeed or you may not. Is given by, remember it's a product rule, so we can multiply the probability together. Probability of getting one success is P. Probability of getting another one is similar, getting two is PP, because you multiply them together, P. How many P are going to have? Okay, you are interested in X successes. So this is going to be X times. Probability of getting one success is P. Probability of getting two success is P times P, because it's an AND combination. Okay, but at the same time, you are going to lose. Remember, what's probability of failure? Probability of one failure is going to be Q, two failure is going to be Q, up to the Q. How many times are going to fail? Remember, it's a binomial. Anytime you succeed, then at the same time you fail. The total number of the observation is N. The total number of that you are going to repeat it. If X out of those numbers you are going to succeed, so the leftover N minus X times you are going to fail. Okay, so this is the number of the successes, this is the number of the failure. But mathematically, this is going to be P to the X, Q to the N minus X, N minus X. Okay, so this is going to be the probability of, this is the probability of getting X successes out of N trials. But remember the way I did it over here for you. There are different ways that you can get these successes and failures. It's not going to be just that. You may switch, you may get a failure or get it, the other way around. As I did it over here for you, you see, there are different ways that you are going to get two successes. For example, you see 1, 2, 3. That was the one. The other one that you get two failures is going to be 1, 2, 3. So how many times are going to see this? This can be done with that formula that I gave you, that factorial one. So in general, if you write the formula, then I explain it. You see the way we are going to put those the numbers that in the boxes that I told you, and the number of the times that you're going to get these failure and successes is going to be this one. In general, P of X is going to be equal to, P of X is equal to the, you see, the number of the time that you are going to, imagine those boxes that I gave you. Those N boxes, you have N boxes, and you have all X letters, successes. You want to distribute X letters in N boxes. What's going to be the choices? You have N choices for the first one. N ways to put X letters in the first box. Then you have N minus 1. Then you have N minus 2. You just keep going. Going up to the what? N minus. That would be your X. It's going to be X minus 1. We can do it right away. It's going to be minus up to the X minus minus X plus 1. And that give you times this probability. P of X Q to the N minus X. Okay, this is a probability that you do it once, and there are various ways to order them together. So that give you the formula. This formula can be written in terms of the factorials so that you can use your calculator. So if you do a little bit of algebra, this is going to be the way you are going to see it. So P of X, don't worry about it. You are going to have a table to evaluate it. So you can do a little bit of algebra to change this one into the factorial form. It's going to be N factorial on the top, because some numbers are missing to get it to the N factorial. Divided by N, make sure you write this one correct, minus X factorial times X factorial. And that would be P to the X, Q to the N minus X. And that gives you your formula, okay? And this is going to be the probability. This is going to be the probability of getting X successes out of N trials. X is going to be number of the successes. In this case, X can be any number between 0, 1, 2 up to the N. This is a binomial distribution formula that we're going to use. If the number is going to be very small, this quantity can be found quickly, but otherwise you can use your calculator. I'm going to show you in a minute how you're going to do it. All of them can be done by a table that I'm going to propose to you. Then you can use those tables when we get to the, when you get to the problem. So I'm going to write down officially, yes, what's question? That's going to be 1. What does the second part of the equation says? The formula. That's it. Let me write it down officially. Different way, to write it down. So officially, if you put them together, really, we didn't need much to be able to do it, but this is the official version of the famous theorem. Don't worry about those factorials. All of them can be done by a table. You don't need to do anything. You need to understand it and identify the P, Q, X, and the R, and then we're done. So this is going to be called binomial. It's a great formula. I can prove it. I did prove it for you, but I can, just do much, much more, but you need a bit of calculus. It's a very nice problem for calculus. So what is a binomial probability formula? You can bring this formula to the test, but just make sure that you need it. You don't need the formula really. You just identify it for us. This is the official version. The probability. The probability of getting X, very bad notation for X, but of course, I just use it for your book, then I explain it, then we get to the calculator. The probability of getting X successes out of X successes out of N trials, repetition is this formula. P of X is equal to those factorials, N factorial, N minus X factorial times X factorials. P to the X, Q to the N minus X. X is the number of the trial, so it must be less than N. X can be 0, 1, 2, up to the N. N is the total number of the repetition, so X cannot be bigger than that. Now, when you use this formula, you need to know the following. P is probability of success. That would be given to you. Probability of success. That would be given. Q is the other way around. Probability of failure. That would be given. You must note that Q is equal to the 1 minus P. So P would be given to use the formula to get the Q. N is sample size or the number of the trials or number of trials. Either one would be fine. Okay, that's saying X number of successes, number of successes, that would be given. Okay, what else? P of X, probability of success, probability of getting X successes out of N trials. That's all we need. Okay, so what I'm going to do, I don't have time to give you examples, but I'm going to give you example. It's very easy operation that we're going to have. Check this table that I posted for you. You see, these are the one. These are the one that we're going to use. This is going to be the formula in short form. So we just identify this P and the Q, and the result would be given from this table right away, or calculator. So you're not going to worry about those factorials. You have to worry about, the understanding the problem. So we give you a couple of examples, and there's 2 parts. We are not going to do the second part. We just talk about the probability case. Okay, so I post a practice test for you. In that practice test, we give one problem from the binomial. So we check a couple of examples on Thursday first, and then we go over that practice test number 2, or when you come back. Okay, that's it. Any question? So I tried to get it to the formula so that we be able to check it. Okay, as I told you, don't worry about everything. What you are going to do really, you identify the P, N, and X. Then you go to this table and you get the result right away, or your calculator. But this table is much easier. So check this one on the canvas. You need it from